Hey everybody, this is Larry. This is September 10th, the 10th day of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think. Ask me anything though. Sometimes apparently I get pedantic and annoyed. Apologize for that. Anyway, today's problem is Arithmetic Slices 2 Subsequence. Okay. Wow, this is like the sequence, or the sequel, and the subtitle. Okay, what are we actually doing? Okay, return the number of all the arithmetic subsequence of nums. Okay, so n squared should be straightforward, and n is 1,000, so n squared should be good. The idea is basically, yeah, I mean, I think there's some variations that we can do, but basically two numbers define a subsequence, right? And I guess I'm just trying to figure it out, or at least three elements. Okay, because then now we can do some maths on this. Because, for example, 2, 4, 6, 4, 6, 8. These are all kind of the same root, if you will. It goes from 2 to 10, and then we just have to figure out some maths to figure out how there is, and of course they actually have this one that they give us as well. So I think that should be good. Let me think about how to do this in a clean way. Yeah, but I think the zero case is the only case where you can have yeah, the zero case is the only case where you have this 2 to the n type thing, because then now you can choose any subset. Otherwise, if you have just a regular arithmetic thing, then you just do the math. Yeah, that should be okay. But trying to think whether that is too much space. I guess not, because at every given space we only have at most n previous things, and then or I previous things, so then it's going to be n squared space, and given that n is 1,000, n squared space should be good enough even in Python. Yeah, so let's do that. Let's do the dynamic programming, and then we'll figure out what is the best way around it. Let me think about this for a second, actually. Because, for example, another case that we can have is something like 2, 4, I guess it doesn't matter, 1, 2, 3, 3, 3. Then what do you do, right? Well, in this case, ignoring all the threes, but this 3 links to this one, this 3 links to this one, and this 3 links to this one, right? So then here we have to be careful about how we want to do it, but we also want to be mindful that we don't double count on the 2, because 2 can never be the end of a, depending on how you want to do it, not the end of a sequence. Yeah, okay. I mean, I think we have to be very careful, but it should be okay. So I think let's do the zero cases first, or the delta equals 0 case where all the numbers are the same. So we can have just do something like collections dot counter nums. What did I click on? Sames is equal to this, and then we could do some math here. Do I have to do mod of something? Oh, I guess they're guaranteed to enjoy 2-bit ints, but in theory, actually, you need to mod this, or at least it'll be a big int, because, for example, if every number is the same, it'll be just 2 to 1,000. So, yeah, okay. So let's just say total is equal to 0. Then in this case, for k in sames.keys, then we just do 2 to the, so power of 2 to the same sub k, the length of this. Oh no, I guess we are doing counters, so it's just this, right? Is that true? Or is that this or this minus 1? Oh, no. This is this minus 2 because we have well, we have to have at least 2, so maybe this isn't power of 2 to that, but no, I mean, I think it's 2 to the power of this minus minus, what am I minusing? Basically, n choose 1, which is just same sub k, and then also minus n choose 2, which is, you know, that's kind of wow. Is this problem really that awkward? Let me think about this for a second. I mean, these counting things, I guess you can do it that way, but yeah, I mean, I think this is a thing. So yeah, so you just choose one of these, minus choose 2 of these. We'll do this for now. I think there's a cleaner way to do it with DP-ish E style, but let's just do this for now and then kind of play around with it. Let's see if that's right. I know that this is technically not the same, but okay, so I'm off by 1. Oh, I guess count 0. So this is this minus 1. 0 being no numbers. So yeah. And this is of all possibilities. And this we have to split minus 1 anyway to get minus 1. So okay. So I think we're good here on this. And then now we have to do the rest. How do we think about this though? So let's just say, you know, what we said earlier, we have I is from range to n. I'm confused. And then sorry, this got messaged very quickly. But yeah, but here we can look at this, and then now delta is just equal to num sub I minus num sub j. And it can go in either direction, that's fine. If delta is equal to 0, we already did it, so we'll just continue. Otherwise, what are we trying to store? I guess because I think my initial thought was to store the count, but maybe that doesn't make sense. Maybe it only makes sense to store the length. And in that case, if we store the length, then maybe that's a little bit better. Yeah. Okay, so then that means that let's just say previous is equal to this thing in a way for now. And this is what we're gonna set my dynamic programming-ish, but I guess it's dynamic programming, but I'm just trying to just cache a lot of things, right? And I don't know that I'm doing this right, by the way. Maybe this is a little bit later on the video already, but you know, I usually solve these live, so it may be a little bit wrong, maybe a little bit slow, it may be a little bit whatever. Watch it on the fastest speed. You know, I think that my value add is versus like every other video is that like you get to see me live instead of having this perfect answer, right? So yeah, if that's not your liking and you prefer the perfect answer, check out other videos. It's fine. I'm not gonna, you know, hold it against you. But anyway, so the previous, so we have this. Let's just say kern is equal to a dictionary. right? And then now, so current of delta is equal to previous. Let's see. So at that point, if there is delta, if delta is in previous of j, then this is this plus 1. If not, then I guess we could have used the default array, but it's fine. Otherwise, this is 2 for two numbers, right, in the part of the thing. And then at the very end, we append current. And is this good enough? Let's see. So basically what I'm here now is that it allows me to answer the question of what is the longest length of the thing that ends in here, right? Of a given delta. And here, I think now instead of that crazy thing that we were talking about, if this is greater than 2, if current of delta is greater than 3, we can add 1 to the total, maybe? No. We can add actually current sub delta minus 2, something like that. The reason being that is that what I'm thinking is that, okay, for example, let's just say we have this thing, right? We have this thing, and now we're up to 10. What can 10 do? 10, we look at the delta of 2, so then here there's going to be a length 5, right? 5, but that means that we have at least 3 sequence, which is 6, 8, 10, 4, 6, 8, 10, and 2, 4, 6, 8, 10. So basically the number that ends here. So then that's why I have this thing. Okay, I think maybe this is okay. Let's kind of give it a submit, or give it a run. See, at least we get if this is the right answer. This looks like it's the right answer. So I think if this was a contest or something like that, I would probably submit. But because I don't want to test, because it's hard to. So the thing with testing during contests, at least for me, and I'm really bad about it, so maybe this is not great advice, but at least for me, it's that you have to come up with the right answer for these. Like, you could generate random test cases or small test cases, but you have to come up with the right answer, right? And in this case, you might actually, like for here, I would not know that 21 is the wrong answer, but of course, in practice, it does tell you like, oh, 20 is the right answer. So then now I can take a look to see why I'm wrong. But yeah, but in terms of yeah, in a contest, I would have submitted and I would have been like, oh, no, this is the wrong answer. And then I would try to work out what I'm doing, which I will still work out. But here, I don't have to submit to do that. So anyway, let's just take a look at what we have in our previous array. Okay, let's see. So nothing in the beginning, that's fine. The previous... I guess that's true. So 4 and 2 is length 2, that's true. I guess this is all good up because in the beginning anyway. Okay, so 10, 6, 2 is 1, so that's good because that means that a 4 has a length 3, which is true. Length 2 for 5, I guess that's good. So okay, so the second 10 is maybe we're having some issues, and it seems like it would match up. So then the question is, though, if it matches up. Okay, maybe not. Actually, let me look at one more. So the 8, this is 8, 8, and the 2 only has length 2. So 8 and the 4 only has length 2. 8 and 2, so 2, 4, 6, 8 has 4. So that means that this adds 2 to this, and then negative 2, which is 8 to 10, doesn't have, only have length 2. Not seeing any wrong results so far, so I'm trying to think why I'm wrong. Okay. And yeah, is there, maybe I'm missing some sequence? I'm missing 7 sequences. So if this is 8, It's just 2468, right? So yeah, I don't unless I have a typo somewhere. We already factored this in, maybe not. I don't know. I feel like we are. But yeah, this is being set, so this is right. So okay. I think I know what is wrong. I think I know what's wrong. I mean, I don't know that this is the reason, but because I think I tried to do this length thing, but for example, you can have just 2 2 4 4 6 6 8 8 10 10, and that would clearly be wrong because I just take the length when it should be the count. Right? So this is off by a lot. How do I handle this, however? I mean, how I handle this is that this should be a count, but then how do we take care of the case where it is at least 3? I mean, I think the short answer to that is that we have to add a dimension. I was thinking about it while I was doing it, but I thought that maybe I could get away without it. I don't know what I was thinking clearly, but yeah. Okay, let's see. How do I modify this? So this is the delta, okay. So if the delta is here, then yeah. Then we can do 3 things. We can say current of delta is equal to, just say this. Yeah, we'll just array of 3 elements, and then it'll be if it is not in delta, then this is just oh, so it has to be. I did 3 number here for 1, 2, and 3, but it can never be 1. So it is either just 2 numbers or 2 or more than 2 numbers. So we only have to keep track of 2 things. And here we just start at something like this. Yeah, okay. And then here, current delta of 0 is equal to previous j delta of no, this is just 1. Hang on. Yeah, this is just 1 because there's one way to have 2 numbers exactly to do this. And then, so okay, let's just do it here then. And then now, then current of delta of 1 is equal to the previous 0. This being that this is basically the number of sequences that had 2 things in the sequence. And then here is the number that has 3 things in the sequence. And I think that should give us a good price. Yeah. And then here, then total is just this, because this is, yeah. I know that I'm not explaining quite well, but let me see if I could get this to be correct, and then I'll try to explain a little bit better. Nope, still quite a bit wrong. So 1 0 1 0 4 4 2 is is that right? I don't think that's right. Two 4 to the 2, so this should be if delta is not in the previous, right? Oh, no, this is the 6, this is not the 4. Okay, so this makes sense actually. But then is there only one of them? Oh, I see. Because I'm not compressing this in correctly. Because delta can appear multiple times in current. Right? Yeah, okay. I think that's why. So, okay. So, if delta not in current, then current of delta is equal to 1 0. Okay. and then now we can do, if this is the case, then we add this. Otherwise, we add this. Is this right? What am I doing with it? Yeah, I think this is okay. Because it does not belong. So this is the first instance of two numbers. Okay. Okay, now we're overcounting. Yikes. Why is that? So 2, so the 4 goes to 1, I think this already, I think I overcounted it because this increment assumes that this thing is 0, 0, so we were double counting. Okay. We got this number right, but then now we fail on the other ones. But luckily, maybe, this one is wrong, so that gives us an easy thing to debug. So let's take a look. Because that is the input and it's just a sequence anyway. Okay, let's see. Let's see. So 2, this one's, the 4 has 1 and 0. That makes sense. So the 6, length of 4 has 1 and 0. 2 would have 0 and 1. That seems right. Okay, I think I'm not adding one thing correctly here. Okay, let's see. So this is the 8. This this is okay. This is okay. Doesn't matter. This thing doesn't make sense. Okay, because this thing now should, the answer should be 2 here because now it has this thing. And if this one, so I'm adding this naively, but I think this should be a formula because now 8 adds to the number of ways that are already 3's, right? Because there's only one way to make a sequence of length 2 to length 3. If they're all sequence of length 3, then how many ways are there? If there's one way, then we can add. Do we have to care about the length? That would make space way more expensive though. Am I doing this wrong? Let's say there are 2 of them, then what happens? Basically, if there's one way to do it, then it becomes 2. What if there are 2 ways to do it? And the 2 is not even clear. Because, man, I'm really bad at this. Because just because there are 2 ways to go back doesn't mean anything. Because, for example, in this case, there are multiple ways to go back, but that doesn't do anything about the length, right? And in this case, we do want the answer for 8, 2 to be 2 because the 2 possible sequences that are here, right? There's one that is am I right? Am I just missing something? No, there should be 2 because even though there's one way to do this in a length 4, but there's also one way to do it in length 3. No, I think I messed up somewhere. Hang on. But I have a better idea. So this one is 1 because it takes the previous one here. It takes 1 from here. but it also I think this 0 is wrong. I think that's why as well, because I think it also creates a another way to phrase it is that it also creates a length of length 2. So then now I think we should be in a better place. Okay, so I think now we fixed this, but apparently we overcounted for this one. Yeah, so the reason why we had this is because now we always create a length of length 2. Okay, but now I have to figure out why this overcounts. Yeah, okay, let's see. Let's start with something even shorter then. Okay, is this right? Probably not, right? It might actually just by accident. Nope, don't. Okay. So here, on the first 6, there's 4. And on the second 6, there's 4 again. Did I just mess up? Oh. I think I just messed up in that I double added by accident. Okay, I think now we're good. And I'll go over the recurrence in a second, hopefully. Maybe I'm wrong here though. But I am adding this multiple times for the same delta, that's why. So I think here I can just do something like for delta in current.keys, just so that we don't double count. I think this should be good. Yeah, okay. Let me give it a submit and then I'll explain it real quickly. This was kind of a harder problem than I anticipated, to be honest, as you can see. But not impossible, just that actually it reminds me of the Q4 that we did way recently on the Leetcode contest. I forgot which one. Yay. But that's the same idea, actually. Let me see if I could pull it up real quick. I think maybe it's this one. With the subsequences, the number of good subset, is that the one? Yeah, I think this is the one, right? Nope, not this one. Okay, never mind. But the idea here is that this is a hard one. So I'm gonna skip over the 0 ones first. I think this one makes sense, right? This is just well, not skip over. I'll just go over it very quickly. Basically, we can take all subsequences except for length 1, length 2, and length 0. Right? So that's basically the formula here. This is n choose 2 or x choose 2. This is 2 to the x minus x choose 1 minus x choose 2 minus x choose 0, which is 1. Right? So that I hope that this one makes sense. And then here's the dynamic programming, which I had some idea, but I got it wrong a few times. So hopefully that makes sense. But the idea for this one is that we keep track of all the deltas, right? And for each delta, we ask ourselves, current subdelta. What does current subdelta store, right? Current subdelta stores basically 0 and 0, 1, so 2 elements. It is the number of subsequences that are of length 2. And this is the number of subsequences that are of length greater than 2 or greater than equal to 3. And here, just add a little bit more. Current is equal to processing the I or num sub I, if you will, and current subdelta is the number of I mean, it contains these things, but it just contains these things for the arithmetic sequence where the last number or the previous number is num sub I minus delta, right? Did I spell that wrong? Yep. How did I spell arithmetic? I can't spell anymore. How that? Oh yeah, the I is here. Okay. Yeah. And then here the previous is basically how do we set up, right? If delta is 0, we already done this in SameSeas. So basically set default subsequence counts to 0, 0. This is base case. Here it goes, okay, if previous sub j of delta exists, that means that we set it previously, and that means that we can use it. Oops. We'll skip ahead a little bit and explain this part first. If previous j of delta does not exist, that means that there are no previous delta. There are no previous deltas for index j, right? And in that case, in this case, we create a new subsequence, and thus with num sub I and num sub j, and thus we have one subsequence of length 2, and this is why we feel this is 2 plus 1, one additional. And here is the same logic. Creating a new subsequence of length 2 with num sub I and num sub j. And then here we create new subsequences of length greater than equal to 3 by one way is to take the previous subsequence but of length 2, and that's this part, and add or append num sub I to it, or take previous subsequence but of length greater than equal to 3 and append num sub I to it. So that's this part, right? As we defined it before. So given these things, now we can calculate the current delta sub I. The reason why we added outside and at the end is because of stuff like this, right? Because if we add in the middle, or we add it afterwards, we double count because for the same delta, for example, let's just say we have 8, 8 here. Let's say you're looking at 8 and you're comparing to 6, right? Well, the delta is 2, but there's also a delta from this one. So you have to kind of merge them together in a good way. And that's basically why we wrote this in a kind of a wonky way. But yeah, and then at the end, you just total all the ways to, So current sub delta of 1 is the number of subsequences of length greater than equals to 3, which is what we want. So then we add that, yeah. And at the very end, we add this to the array so that we can use this in previous later on. And that's basically the idea. Yeah. So that's basically the idea. Kind of hard problem, to be frank. It's been a while on a Friday. Yikes. But yeah. Okay. So what is there to say? Yeah, complexity, right? Well, this one is going to be O of n because this is just based on these this counter. So this goes through the array, it counts stuff, and then it does some math, right? So this is O of n. In this case, this is O of n squared because you have an I loop and then you have a J loop, and everything here, you look very carefully, is O of 1. So this is going to be n squared. In terms of space, this is also going to be n squared because there are n distinct deltas for each one, and there are n of these, so it's going to be n squared times 2 for these things, but still O of n squared. So this is going to be O of n squared time O of n squared space. This is a trickier problem than I anticipated. But that's all I have. Let me know what you think. Let me look at the solution. Let's go over the solutions real quick. Maybe there's a similar idea, but I'm happy with how I did, even though that was a long time. Brute force, okay. Dynamic programming, I guess that's the way that I did it, really. Okay, and they define it as a weak and strong, I suppose, which is kind of what I did. I guess you could have 2 sequences or 2 arrays versus what I did, but the same idea, really. So yeah, okay. So I guess I don't feel that bad about it. Okay, yeah, that's all I have for this one. Let me know what you think. Have a great weekend. Have a great Friday. Have a great weekend. I'll see you later. Stay good. Stay healthy. To good mental health. Take care of yourself. Goodbye.